So coming to these topics, a single phase AC supply is given to pure R, single phase AC supply is given to pure L, single phase AC supply is given to pure C. For these three topics, we will write voltage equation, current equation, and derive the instantaneous power equation and the average power and waveforms. And these five concepts are very important for these three. So coming to the first one, a single phase AC supply is given to pure resistor. Here sinusoidal voltage is given. The instantaneous value of the voltage is V is equal to V max sin omega t. Then the current will flow through a resistor. We know that I is equal to V divided by R. So V max sin omega t divided by R. V max by R can be written as I max sin omega t. Here I max is equal to V max divided by R. And here the first one is over and second one is also over. What is meant by instantaneous power? The instantaneous power P is equal to, it is a product of voltage and current, so Vm sin omega t into Im sin omega t. So that should be equal to Vm into Im sin square omega t. The sin square theta can be written as 1 minus cos 2 theta divided by 2. So Vm into Im 1 minus cos 2 omega t divided by 2. So Vm Im by 2 into 1 minus cos 2 omega t. So this is called the instantaneous power equation. And coming to the waveforms, so voltage waveform and current waveform and the instantaneous power waveform. So V is equal to, what is the voltage equation? Instantaneous value of voltage is Vm sin omega t, and I is equal to Im sin omega t, and the power is equal to, it is a product of voltage and current. At omega t is equal to 0, the instantaneous value of the voltage is 0. Vm sin 0 is 0. I is also 0. And at omega t is equal to 45 degrees, V is equal to V max by root 2 and I is equal to I max divided by root 2. Sin 45 is 1 by root 2, and the product of these two is instantaneous power is equal to Vm by root 2 into Im by root 2, that is Vm into Im divided by 2. At omega t is equal to 90 degrees, then V is equal to V max sin 90, that is V max, and I is equal to I max. Then the instantaneous power is V max into I max. At omega t is equal to 135 degrees, V is equal to, so V max sin 90 plus 45, so cos 45 is Vm by root 2 and I is equal to Im divided by root 2. And the instantaneous power is Vm into Im divided by 2. At omega t is equal to 180 degrees, V is equal to 0 and I is also 0, and the instantaneous power is 0 because the sin 180 is 0. At omega t is equal to 270 degrees, V is equal to minus V maximum, I is equal to minus I maximum. Just substitute the values in the equations, and the instantaneous power is V max into I max, because minus V max into minus I max is a positive value. At omega t is equal to 360 degrees, V is equal to 0, I is 0, and the V instantaneous power is also 0. Okay, so here the space is not there. Now I am drawing here voltage, instantaneous value of current, and voltage and power. So first of all, I am representing voltage. This is on x-axis we are representing the time, that is omega t, at 0 degrees, 45 degrees, 90 degrees, 135, 180 degrees, and after that is 270, 360. Okay, you will take 215 degrees like that also. At 0, if you observe at 0 degrees, the voltage is 0, as the magnitude of the voltage is 0. At 45 degrees, V is equal to V max by root 2, as this is a value, V max by root 2. At 90, V is equal to V maximum. At 135 is V max by root 2. At 180 it will be 0. At 180 it will be 0. At 270 is negative maximum. At 360 it will be 0. By adding all these points, then I got the sinusoidal waveform. So this is the voltage waveform. Coming to the current, both voltage 0 points and maximum points are taken place simultaneously, because in a equation V is equal to V max sin omega t. Similarly, I is also same, sin omega t. Both are is in same phase. If you are represented in phasor manner, this is a voltage and the current, both are is in same phase. Why? Because the phase difference between these two is 0 degrees. Phase difference. At 0 the magnitude is 0. At 45 is 1 by Im by root 2. At 90 it is maximum, and this is the value. And 180 it will be 0. You will check it. At 180 it will be I current is 0. At 270 is I maximum, and 360 is 0. If you join all these points, then I will get the current waveform. So this is about the current waveform, instantaneous value of current waveform. So by product of these two, voltage and current, will give the instantaneous power. Observe this. Why I am taking the less magnitude means, so V max can be assumed as V max is greater than the I max. Okay, both 0 point and maximum points are occurred at simultaneously. 0 into 0, 0. The instantaneous power is 0. At 45 degrees, see here, V max into I max by 2. At 90 degrees, both are maximum. Let us assume V max into I max. V max is 3. I max, let us assume it is 2. 3 into 2, it is 6. That is more than this maximum point of the voltage and current. And 180, it will be 0. So at 135, yes, you will have this type of waveform. And Vm into Im by 2. So by adding this one, then you will get the one cycle. After that, at 270 degrees, you will see minus Vmax is the instantaneous value of the voltage. I is equal to minus I maximum. The product of these two will give the positive. So negative into negative is positive, and 0 into 0 is 0. By adding this, then I got the power waveform. This power is called the instantaneous power, and we can derive the average power as the average power is in DC. What is the time period of this waveform? The time period of the power waveform, the time period as the power waveform is pi only. not 2 pi, not 2 pi. Why? Because what is the time period definition? Time required to complete one cycle. When the voltage waveform completes one cycle, but the power waveform completes how many cycles? 2 cycles. So that's why I got it as a cos 2 omega t. So then we have to derive the average power is equal to, so average is equal to 1 by pi, so length of the base, and integration of the 0 to pi instantaneous power into d omega t. See, sorry, this one is omega t, right? Yes, omega t. 1 by pi Vm Im by 2. What is the instantaneous power? Already we derived 1 minus cos 2 omega t. So 1 minus cos 2 omega t into d omega t and 0 to pi. So Vm into Im divided by 2 pi. Integration of 1 is omega t. Integration of cos 2 omega 2 is t is sin 2 omega t divided by 2. The limits, lower limit is 0 and the upper limit is pi. Integration of cos 2 theta is equal to sin 2 theta by 2. Vm into Im by 2. So if you substitute the upper limit pi minus sin 2 pi value and lower limit is minus 0 and plus sin 0. Sin 2 pi value is 0, sin 0 is also 0. Then I got it as Vm Im by 2 pi into pi, and the pi will be cancelled. Then this can be written as Vm by root 2 into Im by root 2. So Vm into Im by root 2 can be written as Vm by root 2 into Im by root 2. Then the average power is equal to Vrms into Irms. See, once again coming to this point, and this one is first one as the voltage equation is completed, and the second is current equation, and after that the instantaneous power equation, as is the third one, instantaneous power equation, and fourth one average power, and fifth one is waveform. By drawing the waveform only we can tell that what is the time period of the power waveform. This is 1 by pi only, integration of 0 to pi, p instantaneous d omega t. Time period is pi, it is not 2 pi. So overall average power for AC supply is given to pure resistor is Vrms into Irms.